All right, check out this one. This number one says the derivative of a function is given by f prime of x equals 2x squared minus 7x minus 4. Determine the intervals that for which the graph of f, the original graph, is increasing. So this is a little bit different. They already give you the derivative. You approach it just like everything else. This is actually pretty nice because you don't have to take the derivative. So we have to find the critical numbers, and that's where the derivative equals 0. So we have to figure out where this equals 0. Let's factor it up here quickly. Factors of -8 add up to -7 are obviously -8 and +1. So you do it however you want. You can do the little diamond or whatever. Either way, you should get x minus 4 times 2x plus 1. FOIL this out, just make sure it's okay. The critical numbers then are x equals 4, x equals -1/2. So we're looking to see where this is increasing, so we're going to make our chart. Pick a nice test number in here, -10, in here, 0, in here, 10. Plug it into your factor derivative. So for -10, we have a negative times a negative, which is positive. For 0, we have a negative times a positive, which is negative. And for 10, we have a positive times a positive, which is positive. It's asking where this is increasing. It's where the first derivative is positive. So it's increasing on -infinity to -1/2. And then from 4 to infinity. Easy. So let's do one that looks a little bit more complicated. But it's not going to be that much more complicated. This derivative is a little bit more complicated. It also says that this function has a vertical asymptote. You can't tell by the derivative, but this is telling you it has a vertical asymptote, x equals -1. So we're going to determine the x coordinates of the relative minimum. So we're going to assume that this is continuous everywhere except at its vertical asymptote. So the first thing we have to do is find the critical numbers. So f prime equals 0 when the top, which is x plus 5, x minus 5, equals 0. So x equals -5 and +5. The bottom equals 0, obviously at x equals -1. It's not a critical number, but we need to consider it. So just that's a vertical asymptote, not a critical number. So when you make your chart, you need to include -5. You need to include the asymptote and +5. We're only looking for the relative minimum, so I'm not even going to write in the intervals. I don't really care. I just want to know at what intervals it changes. For minimum, that means when the first derivative changes from negative to positive. So f prime of -10 would be positive over a negative. F prime of -2 negative over a negative, f prime of 0, negative over positive, and f prime of 3,462,728.6523 is positive over positive. So we're looking for the minimum. That's where the derivative changes from negative to positive. So we have x equals -5 and x equals 5. Now I can't get the y coordinates here because I don't have the original function. It does say determine the x coordinates. So good. One more thing. Say this was asking for a relative. Well, let's just here's part B. Determine where f has a relative maximum. So you can use the same chart. If that's where the derivative goes from positive to negative. So it looks like it would be right here, but luckily you took my advice and you drew a dashed line for the vertical asymptote. So there's no point here. So basically it's just going up and then down here. So maybe there is no point, there's no min or max. So we're going to say nowhere. So the next one I'm going to show you is one that involves trig. So watch that. That's going to be a separate video.